Hello, my name is Keith Parsons, and today we're going to talk about the Wi-Fi stress test. This was a vendor-independent access point analysis brought to you by wireless LAN professionals. Let's get on and talk about the results of the test. First, before we get into the results, we have some caveats here. Again, single point test, only one AP. Second point, we used MacBooks and we used iPads. And some people said, wait, are you like on the payroll of Apple? No, we just like them. And since it was our money, we bought stuff we liked. Of course, if you used Android devices, Android tablets, or Windows boxes, you might have got a slightly different issue. But the frequency is the frequency, and Wi-Fi is Wi-Fi. So take that with a grain of salt. We didn't test the other issues, and they really matter when you're picking out something. AP code versions we've requested, and we will be publishing in the future the actual code that each AP had while the access point was being used. We asked whoever was setting it up to give us a URL, so it's publicly available. They couldn't use any special firmware, and the configs they used are documented, and we'll get those out into the future and get those published as well. But everything that we used was published. It was not any special, custom code just to beat this test as it came along. So our test environment, it was a classroom. Happened to be a portable classroom. Had 30 iPads that we laid out. The 30 iPads themselves each had a little mark on the table so we could replace and put them in the same spot. We had an FTP server, iPerf server, video server sitting in the back in a rack. That also housed a FortiGate router, which provided DHCP, DNS, and NAT. We had a Cisco switch. It was non-PoE. It was just to connect all the wired stuff up. And then we had multiple MacBook Pros. One in the back was running FTP. The one in the front was running iPerf. And then this other one over here was running Zap. And we ended up dropping the Zap. We just stayed with the standard. Some people said, Zap used to be a Ruckus protocol. We didn't want to fight over someone complaining that it came from Ruckus. It's currently open source now. I like Zap as a tool. It does some great statistics. But rather than take the flak, we just dropped it out of the environment. So the classroom was a portable. It had very thin walls. We actually measured. They were 3 dB walls. I have to thank Canyon School District allowed us to use the room, both for the week before when we were prepping to get the room ready, as the week during the test. The room happened to be 32 by 28. Had 6 tables. Each iPad was sitting on a table. We had little blue tape marking where each iPad was so that it would go back to the same position. What we're looking for was a repeatable yet arbitrary position. I called it, we wanted each iPad to be inconsistently consistent. So in class, kids would hold the iPads in different positions, but in order to have repeatability, we took each iPad, each was in a different orientation, but they all stayed in the same orientation over and over. To monitor the test, we used MetaGeek's IPA for packet analysis, Channelizer Pro for spectrum analysis, Air Magnet Analyzer Pro for utilization and throughput, and the Fluke Air Check for spot checking. These were shown on screens, so anyone in the room who was watching could watch them as it was going on. And on the center screen, we showed the current device that was being tested, its management interface. Just a quick little layout showing we had 30 iPads, a bunch of stuff, servers, etc. Some people just like to see this type of 2D diagram. Now onto the testing process. The testing process was the same for every single access point we tested. First step, we would take each of the wireless clients, both the iPads. We had a couple of iPad minis and some Apple TVs we never ended up actually pushing, but we'd have them all configured and tested. We would reset them all on the iPad, settings, general, reset, network settings, and so it would wipe its network settings out. Did the same thing for the MacBook, so they were all clear. So first, everything's all clear. Once it's all clear, we would then turn on the new test access point. The access point would come on. It had a specific SSID. The SSIDs were actually vendor name, AP name, and then a 2.4, a 5 gig, and a test. The 2.4 is 2.4 only. The 5 gig is 5 gig only. And the test SSID was for band steering. We ended up with all the access points and all the MacBooks all went to the band steering one. We didn't actually use the 2.4 or the 5 gig in this round of tests. We then took, and after connecting all of them, so they're all associated, all the MacBooks, all the Apple TVs, all the all of the iPads, once they were all connected, we then put them all to sleep. So they were no longer sending packets in the air. Then we took one MacBook and ran FTP. FTP down, 600 meg file down, 600 meg file up, took the time. Then we went to another MacBook and did an iPerf test, 20 seconds of pushing packets up. That was our no-load test. Wrote down all the results. Then we started the first 5 iPads. All those 5 iPads would run the same video off of the same local video server that was in our server rack. Then after the 5 iPads were up and the videos were all running properly, we would go back and run FTP, iPerf, and run the tests again, while we watched the iPads for errors. Now obviously, as you can assume, as we added more and more iPads, the FTP times went down, and you'll see that data in just a second. Also, as we added more FTP, we got more errors on the iPads. Then we would add 5 more iPads, run the test again, add 5 more iPads, run the test again, and we would keep running the test until either more than half of the iPads were dead, as in weren't transmitting data, or the FTP server gave us an answer of more than 20 minutes before the next run, and we only allocated 90 minutes per access point test, and we didn't want to run that long. There's only a couple that the FTP was actually the cause of the ending. So, iPad errors. This was not automated. This was terribly manual. Lots of warm bodies in the room, lots of volunteers who were needed to do this next test. And one of the volunteers was dedicated to tracking the video artifacts. Now we tracked those on a little sheet. The sheet itself had space for 5, 10, 15, 20. And while we're running the 1 to 5, he would use the 1 to 5 column. And we had a thing we just called a tick. So if there was an iPad and it was going along and it artifacted, seeing little fuzziness, slow down, whatever, that didn't count as a tick. That's just artifacting, and we let those go. It's more of a quality issue and kind of hard to capture that artifacting. But we did the next step is if you had the iPad sitting in front of you, the video's playing, and the video stops, and the player itself pops up a little triangle, the little play button, and you have to push the play button again to start the video, meaning it had stopped receiving enough data that the player said, I'm done, do you want me to play? If you click the start button, you'd get 1 tick. Now how we captured that tick is whoever was standing in front of a row of iPads would go 7, 9, oh man, it's not started, 9, and would count them out loud. Someone would check those ticks. If a individual iPad had more than 10 ticks, we counted that as dead. We would take the little 10 little tick marks and turn it into an X saying it had died. And then so that it continued to pull a load on the network, we didn't want it just to disappear, we would restart the Safari browser, go into the, click the little start button on the iPad, close Safari browser, reopen Safari browser, reopen, and let the video start again. So it continued doing it. All dead iPads, as we move from column 1 to column 2, they all got resurrected. So if there's an iPad that had died in the 6 to 10 test, well, it got resurrected, and we could, play it again on the next column over. And then we just added these up. Throughput calculations, we took the FTP download of a 600 meg file, FTP upload of a 600 meg file, iPerf upload for 20 seconds, and then we ran a zapper, which was a 100 UDP uploads. The zapper was not included in the throughput calculation, by the way. We just ran it to get a visual clue of how healthy the network was. And then the throughput calculation for aggregate throughput is the total of all packets, total of all bytes sent, divided by the total of all time, gave us a raw number, and then we scored them accordingly. So a couple pictures for you, testing in process. You can see warm bodies, little bags of water hanging around each of the APs. And we couldn't replicate students sitting in front of each one, but we had volunteers working them as they would go on and off. We powered up the iPads to make sure they had enough power, but during every test, we unplugged them so they'll be running on battery power because iPads react to Wi-Fi differently depending on which one they're running. And we just sat and watched them and set the little ticks. That was the process. Now not everyone, but most people who came to the lab said, what size is the video stream? How big is the stream? Is it constant bit rate? No, it's just a big pipe. It's a whole bunch of data. To prove that, we took the MacBook that was used for FTP and hit the exact same location, the same web page that had the HTML video player on it, and with a MacBook that had a 3x3x3 chipset could push up to 450 meg. When we went and clicked to play the video, we got the video to download at 120 megabits. It was not a constant bit stream. It was just a bunch of data. It just happened to be video data. All iPads had to share the same bandwidth with everything else on the frequency. So people go, well, how big was it? Well, it depended on how many were talking at the same time. When we looked at some packet traces later, between 2 and 3 meg, each individual iPad could pull. But it was really based on what other load was going on. So to really push the video server, we wanted to show the video server was not the bottleneck. We took 30 simultaneously videos on a MacBook Pro, all going through its wireless port, hitting the same video server over an AP, and then looked at the wired port that video server is connected to, and we were pushing about 240 megabits. We had an SSD that was being run on there, and that VM that was running the video server had 16 gig of RAM. So it wasn't the video server was the bottleneck. We chose, inside Wireless Sound Professionals, before we went to develop this, and it took us about a week to do this tuning, we wanted a goal to have all the access points fail, within our resources. We only had 30 iPads. If everyone had finished all the way through and no one died, we wouldn't have any good data. As it was, not one access point could complete the entire test. One of the things we had started with is we were going to originally have 3 Apple TVs and 3 iPad minis giving a background load on top of what we tested. And when we had those 3, most of the test run would only die at 1 to 5 iPads. So we pulled those out because we'd like to tune the test so it would die at the right place. We also tuned the size of the FTP file. When it was too big, it took too long, and we couldn't stay within our 90-minute test window. When it was too small, it didn't take long enough, and we would die outside the 30. So we wanted it to match the environment that we had. And we chose 1080p HD quality video, big fat video file to push down. That was tuned specifically so we could get failure within our bandwidth. Now the results. Woohoo! You've all been waiting for the results. So, throughput results, we'll talk through those. Video error results, and then we'll talk about the individual access point results. So, under throughput, let's talk about this. Up to the right is better. The blue line is the maximum that any one individual AP had. The red line is the average, and I know this is the mean. Some of you ask, what about mode and median? Now, this is just the mean. I didn't want to mess everyone up with more statistics. And the green line was the minimum that happened. We happened to also drop this little purple line at the bottom, which is the standard deviation in between there. But you can see it's kind of a nice curve there. The more iPads we added, the lower the throughput, as you'd expect. What you probably didn't expect is this big gap right here. There's a huge gap from 48 to 21 under no load. From the highest to the lowest, that's a big gap. Even from the average to the height was a big gap. You'd anticipate most access points with a single client, nothing else going on, would be pretty close. Wasn't so. This one's really busy. Same up to the right as we had on the last one. Each colored line is a different access point. And yeah, we don't want to have that. It's just too busy, hard to see what's going on. So instead, we're going to show those each individually. Under this series, we have bar graphs now showing the highest, 48, down to the lowest at 21, plotting each of them as they're here. And the black one in the middle is the mean, the average of what's going on. So you can see how many were higher than average, lower than average. Under low load, again, we had a differential between them all. Pretty big differential, actually. As we added more iPads, as you'd expect, the average went down, but so did all of the winners. The high one now is no longer 48. It dropped down to a little about 31. The low went from 21 to 7. So we lost about 25% on the high end, and we lost 2/3 on the low end. So the low end is starting to move. Average is shifting over a little bit. As we moved down to 10 iPads, we actually had an AP drop out. It couldn't carry any more data at 10 iPads. Video wasn't working, FTP didn't work. And you know, also lower, the high end went from 30 down to 20, lost 50% or so, about a third at that point. And down here, we're all the way down to 0 at some of them. And then as we add more, our range drops, still coming down. And finally, as we go to 20, there's now only 4 APs left. All the other ones weren't able to carry the 20 iPads and FTP at the same time. First shocking kind of thought there. Of our 16 tested APs, only 4 were even able to handle any data at 20 iPads sending video. That's kind of a shocking piece of information. Again, we tuned it so they die inside there, but that's a pretty low number. Next one, iPad video error statistics. Again, these are averages. We have down to the right is better. What we want is to stay as low as possible, the minimum number of errors. And as we added errors, when we cleared 100, which basically was more than half of the more than half of the iPads were dying, weren't able to maintain their connection, they kind of tailed off. Sometimes it was the iPads dying that tailed off. Other times we might have had iPads, but then the FTP had stopped, basically. Sometimes FTP went down to 50K or lower. Once it is actually in bytes, should be in meg, dropped to K, and then when it was just showing you just bytes alone, it's pretty dead. On the red line is the average, and the blue line is the minimum. So the minimum, some of the minimum guys already had errors at 5, and some died within 10. Again, a very crowded one, showing all possible combinations. Kind of hard to see this, and people said, well, can you highlight my color? Yeah, so instead of showing them all, comparing all 16 against each other, that's just too many lines on the screen, we opted to show each of those individually. Now let's look at the iPad errors over time. So under 1 to 5 iPads, pretty clean. Most of them could handle it quite easily. A couple had some errors, 20 errors or so. And 20 errors, could be 2 dead out of 5. That's not good. But most of them did a really good job. As we moved up to 6 to 10, now only 1 couldn't handle it. The rest could handle 10 fairly good, some with more errors than others, and some looking pretty good over here. Now when it got to 15, we lost basically about half of the iPads, couldn't handle it anymore. That's just 15 alone. The others were hanging in there. Some had more errors than others, but we'd already tailed off a couple of them. And then finally we get to 20, you can see more than half of the iPads are gone, and a couple of them along the side are still hanging in there. We like to hang in there. And we finally get to 25, all but 1 were dead. And then, at this point, the only one that was left, we took that one, turned off the FTP, so there was absolutely no load except for iPad videos, and tried to push it to 30, and it couldn't even handle the 30 iPads streaming video without any FTP in the background at all. So, yes, we took them, the frequency and the access points to their limit. Now, I'm going to get to the rankings next. Well, a quick little caveat. Some of the vendors who were there stayed all week and tested later in the week. They had an advantage. They saw what worked and didn't work, and they could adapt. So, kind of tough to slide those around. I'm just putting that out there. That was out there. Again, single access point, no multiple APs. In between tests, sometimes we had more people manning the iPads than others. And people are just bags of water. Some of us are bigger bags than others. But we're all causing some level of density. We also thought during the test that we would see certain positions. Some of the iPads were standing up, some were this way, some were this way, some were rotated portrait versus landscape. And we thought there was going to be some non-random occurrence where the position might make a difference, or the iPad's number, it's the first or second to join, would make a difference. And in the room, we had feelings. Now, we didn't have good statistics because we hadn't collected them yet. We were in the process. But we get a feeling this AP is doing really good. And I thought there were some feelings, and some other people would even comment, yeah, number 9 feels really bad. But when we looked at the statistics, the actual raw data that came off of these, there was purely random which iPads aired. It wasn't standing up or laying down. It didn't matter what the orientation was. So the assumption was that mattered. It really didn't matter. We also had another assumption that the feeling that some access points did extremely well in the video and then died. Well, one of them took 5 iPads, perfect video. FTP download with 10, perfect video. And then as soon as we did FTP upload, all 10 died. So it felt good for the first 10, like the first half of the 10 felt great. But then when you look at the data, you go, oh yeah, it died really quick. So the other rankings, the better you're able to use the scarce resource of Spectrum, the better you're able to do. Some vendors had on-site SEs, or some even sent engineers from the factory to come help, and others didn't. Some dialed in remotely to do the configuration, and some we just we didn't have any help, so we just took one of my APs and put a default config on it. Apologize for that. We asked. Everyone had the same opportunity to come, and some did and some didn't. So yeah, it's not exactly fair because we weren't doing apples and apples, but this is as close as we could get. And again, we didn't report on features. We just reported on this one set of statistics. For all the individual reports, you can go online. There's a link on the web page and on the screen that will show you where you can go and get the report that lists all the individual reports. There's also a separate video that has just a quick review of each of the access points and how they compared to average. You might want to look at that as well. Thanks for watching.